with the sixth lecture. In this lecture, we'll study the output impedance of non-inverting amplifier. In the last lecture, we studied the input impedance for the same amplifier, the non-inverting amplifier using op-amp. Right. The output impedance is Z out and I of a non-inverting amplifier is V out over I out. So this is the first thing that we can conceive, that the output voltage divided by the output current will of course give you the Z out of non-inverting amplifier. But let's see what should be the starting point. V out is AOL this voltage that we get here, minus the voltage drop across the C out. So since this voltage drop is very small, therefore V out is approximately AOL times VD, where VD is the difference of voltages applied on the input and AOL is the open loop voltage gain. So VD is V in minus VF. We have studied a number of times earlier in this course. V out is AOL times VD, where VD can be written as VD can be written as V in minus VF. So we can replace VOL, VN, we can replace VF with RI over I plus RF times V out according to voltage dividers rule we studied in last lecture and in many previous lectures. So AOL VN taken to the left hand side and V out we take it to the right hand side. So that takes you, if we take, or in other words, if we take this whole term to the left hand side, we are left with AOLV in on the left hand side, and then we can take V out common out of these two terms, and the net expression is this. Since this V out can be replaced with I out Z out in. V out is I out Z out in because we started, this is our starting point. This was our starting point, that V out is I out times Z out in. So V out is replaced with the starting point I out Z out Z out and I. Right. So if you plug this value here, we are left with this, and if we divide this I out here, so the expression on the right hand side is this, and AOL V in over I out can be approximated as C out using when there is no feedback. So this is AOL V in over I out is actually the output voltage without feedback divided by the I out, the current, and the current without feedback. The output voltage without feedback divided by the current without feedback gives us C out without feedback for the operational amplifier. So the expression on the right hand side remains the same, and except we divide the left hand side with this ratio, with this whole stuff, gives you Z out of the non-inverting amplifier. This is Z out over 1 plus something like this. So it gives us an idea about the Z out of non-inverting amplifier. Of course, that would be very small because the quantity on the denominator, is very large because of this AOL. It's a very large value times this fraction plus 1 still gives a very large value. So Z out divided by a very large value will give you a very small value Z out and I that is much smaller than Z out. So this is another advantage, that the output impedance of a non-inverting amplifier with feedback is even smaller than the output impedance of op-amp without feedback. So Z out, if we are given an op-amp as an example, we are given an op-amp where C in is 2 mega ohms, C in is 2 mega ohms, AOL is 200,000, and Z out is 75. It's already very small, and we see that when we apply the feedback, the input impedance is increased to from 2 mega ohms. It is further increased to how much? 17.4 giga ohms, very large, and Z out is reduced to 8.6 milliohm. It's not mega, it's milli, 10 to the minus 3. So this is actually 8.6 divided by 1000. Very small. So that is the advantage. That is the advantage. It's a great advantage that using feedback we can have amplifiers that have a very large input impedance, very small output impedance. And ACL is 2.3. It's controllable using the values RF and RI. Right. Thanks. That's all for this lecture. We'll continue more about op amps in our upcoming lectures.